Many people regard you as a personification of Ubuntu. What do you understand Ubuntu to be?
In the old days when we were young, a traveler through a country would stop at a village and he didn't have to ask for food or for water. Once he stops, the people give him food, entertain him. That is one aspect of Ubuntu, but it will have various aspects. Ubuntu does not mean that people should not enrich themselves. The question, therefore, is, are you going to do so in order to enable the community around you to be able to improve? These are the important things in life. And if one can do that, you have done something very important which will be appreciated.
The open source report on the 2nd of September 2018 from WBRNRadio and on the Boston Red Network. We always start these episodes with the late President Nelson Mandela describing what Ubuntu is as a concept. It's a living concept born on the African continent, and it is about a community. The simplest way of summing it up, community. And we hear a lot of this from various quarters these days talking about community. Some of the commercial enterprises that have open source projects are groups that are part of the community out there to reach out to the larger community, normally around their products, not all the time around their products. And you have the open source developers community that are open source people that develop various applications and put it into the community, usually under the license from the Free Software Foundation. We are now in a transition from, say, open source, the confusion, to Libre, our free software. We started out here at Cranston Software in 1988 with shareware, which was effectively something that you could download and use it, and if you liked it, you could make a donation to the author, which is basically about the same model as open source, but however, on the shareware, the author retained the code. Under open source, at least the general license, the code is shared with the community. Anyone in the community or any individual can modify the code and use it for their own objectives, period, but they must submit back to the community on the most of the licenses, on their different licenses, the modifications. Now, we do have other licenses, primarily coming out of the Apache Foundation, which needs to change their name, and that's one of the unfortunate things. We've been trying to get that name changed since the 90s. And many times there's not the sensitivity there of naming it after an Aboriginal tribe, but like the team in Washington, and we don't need to mention who they are, and various other teams out there. The one in Atlanta, these are Major League Baseball teams that demands have been made to change their names. And we had a name change in the North Dakota hockey team from the Sioux to just the University of North Dakota. But there are people still struggling with that. The advancement of civilization advances in some facets slower than in others, in the anthropological, the sociological. But the economic drumbeat is ongoing. And we started out in our numbers man unit, that's a macroeconomics division of the Boston Red Network, spotlighting on a macro. And we also did shows at one time on the economics of information technology as such. And we'll probably this season put a show up there on our Numbers Man part of the Boston Red Network and WBRNRadio, talking more about the economics of information technology in terms of software, particularly as open source software, various license, versus commercial software. We know that in terms of economics that the open versions are much more applicable. I remember having a debate with a lady in one of the large law firms in the U.S. about that and where it was going. And what we had was some of the commercial software developers that used parts of open source software and were claiming that effectively they arrived at a new product. And that was litigation. It's still out there. We'll have to bring an update on some of that litigation that continues. But one of the things is prominent these days since moving to the cloud. Even Microsoft in their Azure cloud unit has to recognize open source because open source software is the cloud. And this is basically back to the roots of software itself. The Unix movement, with Unix, at one time, the various operators, IBM, etc., they sold hardware. And they gave away at the time, now this was commercial licensed software, but they gave it away with the hardware. Now we are back to a situation where the hardware and software are in, quote-unquote, the clouds. In other words, they are on servers all over the world. Now, when we started out, I remember the punch cards, we go back that far, on the VAX, etc., that we rented a computer time. In fact, that's the same thing you're doing in the cloud, but you have more items to rent than just simply you running, say, a Fortran program or whatever type of program you were running at that particular time. Now you have many, many programs that are being run. You have containers, Kubernetes, etc., and other products that manage these open source programs such as Cloudera, I'll get them right here in a minute. That is more of a management type GUI there upon some of the software developed by the Apache Foundation. And those types of software are open to anyone. You can download them and use them, modify them, etc. That is one of the contributions of open source. Now we're coming more with open source hardware. We're not there yet, but we see some open source hardware, particularly with the Pi boards that are out there, and also with other types of hardware that are readily available that one can use for experimentation purposes or any other purchase for that matter. So we're seeing some advances there. There is also a symbol you can put if you decide to open source your hardware, and there is crowdfunding available to people. Guino was one I was thinking of, become very, very popular with many of the enthusiasts. So we're seeing more and more of that to complement the software. And of course, with the cloud, the cloud runs on Linux, and there are various versions of Linux out there. There's no doubt about that. And as we normally do, we start with the kernel. This is a little bit of a commentary here, but we start the actual program with the kernel, and we are now at 4.18.5. That's a stable kernel, and the long-term kernel is 4.14.67. I believe we have 4.1.4.66. That is the Slackware, a present kernel that we are using out here. So a little different situation there, but any of these kernels are definitely good to use. And just looking at a little article here, This is from a Network World. We get it all the time, and this is the Linux 4.18 better security, leaner code from Network World. We'll just start with this since it was here. The latest version of Linux kernel clears out nearly 100,000 lines of code and adds file encryption and the Berkeley packet filter plus makes nodes to gamers and a node to gamers and mobile devices. Continually moving here. The recent release followed closely by the release of SS 4.18 and 4.81 and 4.185 brings some important changes to the Linux landscape, along with the boatload of tweaks, fixes, and improvements. And let me just make sure this is by Sander Stocker, and it is in a Network World. Anyway, while many of the more significant changes might knock the socks off of developers who have been airing their achievements for quite some time, the bulk of items are likely to go unnoticed by the broad expanse of Linux users. We'll take a look at some code cleanup. For one thing, the 4.18 kernel has brought about surprising removal of nearly 100,000 lines of outdated code. And this is something you would not have in commercial software unless there was a complete rewriting of it. There's lots of code. Does this mean that any of your favorite features may have been ripped out? This is not very likely. The code cleanup means that a lot of code, deadwood, has been carefully expunged from the kernel, along with one significant chunk. As a result, the new kernel should take up less memory, run a little more efficiently, and be less vulnerable to attacks. And this has been one of the long concerns about Linux. And when Linux came about, the updating and security feature, one of the significant chunks of code shrinkage mentioned above refers to the removal of lustre file system, which had been in the kernel, though not fully integrated for roughly 5 years. It was a removal because it hasn't been moving forward at a significant pace to maintain it in the kernel, as premature or incomplete code. Lustre, which is a distributed file system used in cluster computing, may be reintroduced into a later release after its developers have taken time to gather this feature into a better shape. The introduction of BP filters. BP filters, it is the Berkeley package filter. While starting out as a pocket filter facility for other tools, that is a TCP dump. BP filters is poised in 4.18 to evidently replace both IP tables and INF tables. It also expands the capabilities of Linux in several areas: networking, security, load balancing, performance monitoring, without impacting to be performance. In essence, BP filters, or Berkeley pocket filters, represent something of a foundational shift for both networking and security. What is expected to be a very easy transition from earlier technologies, BP filters will provide easy ways to translate IP table rules into its own rule format. Also provide a flexibility with respect to where filtering rules are applied, and maybe the network interface itself, and ways to modernize and revitalize the network stack. Spec file system encryption, that's called FS CRIP, will operate at the file level rather than at the block device level in 14.18, spec 128, spec 256 encryption algorithms. This change makes spec an option for file encryption, although it has met with some controversy because it was developed by the NSA, and that organization may not have shared all the aspects of its design. While some may opt not to use it, it does provide what seems to be the only encrypted option for low-end Android devices, and this plays across and others. Faster and better graphics. The kernel provides improved open source graphics drivers, and won't go into most of those. From AMD's Radeon graphics cards, drivers incorporate code from future Vega 20 GPU graphic cards, along with support for Vega M hardware. Radeon graphics found in Intel's Cobalt Lake G processor. There's also improvements in Hyper-V support for both Vega M and NVIDIA. Volta hardware there changes promise to improve some super fast pixel pushing. Sound chip enhancements. Significant sound chip improvement included in 14.18, but includes improved support from Creative Labs devices. Audio on the HP Spectre 360 laptop, and a state of RETAC chips and MediaTek controllers. Stream controller drivers. Gamers will especially appreciate reverse engineered stream controller driver that allows a device to work as normal as a normal human interface input device right out of the box. Users will not have to separately install stream clients or controller drivers. Performance improvement. A restartable sequence and mechanics for lockless concurrent control in the user space, including the new kernel. RSQ system allows for faster user space operations and has improved in select micro benchmarks. It also provides some important improvements in the kernel's scheduled code. Another improvement in Linux 4.18 provides an improved support for dual lane transfers in USB 3.2, speeding up data transfer to USB devices from host device and devices using Type-C cables. As far as USB 3, slow adoption there. This is what, 3.2. I think our boards only have 2 on them. Perhaps one has 3 there. It is much, much faster. And at one time there was a big debate about USB versus at the time Blu-ray and etc. Blu-ray being a very short transmission of protocol used mostly in smartphone to earphone, matter of a few meters, I suppose, a few inches, how you want to put it. No Y2K in 2038, the new kernel also introduced significant progress towards warding off a long recognized 2038 problem. It's if you're old enough, you might remember Y2K, been only 18 years ago, the millennium bug that led many people to worry about the near end of 1999. There fears that the system application using 2-digit years in their date field would be on the stroke of midnight, and that was 31st of December. Suddenly decide that it was 1900. Didn't happen. A similar problem won't hit those systems until, let's see, January 19, 2038, a long ways away for many of us. Some other changes, the Fuse file system, the ARM Spectre integration fix has been provided for 32-bit ARM devices. Support for Qualcomm's Snapdragon, that's a fast mobile, 845 processor. Complete Raspberry Pi 3B and 3B Plus support has been provided. That is very good, and the power management updates to help performance on both the server and PC level. Now, that's one of the things with Linux. Linux edition most editions, that is, can be used both as a server and or as a client. None of the others can do that. Native Thunderbolt support on Dell hardware is added. Detailed changes, of course, can be browsed at the kernel new bytes. And to conclude this up, the 14.18 kernel is bringing lots of welcome changes for performance, security, functionality to the Linux system, and maybe now we can stop worrying so much about what's going to happen in 2038. Well, 2038 is a long ways out there for us old timers. We'll put this on the Cranston Software Facebook page. It'll be there for your perusal, and also on our Twitter feed. You can find that at Cranston Software. And we'll also put this on our Cranston Software WordPress page. So in other words, we'll distribute this around where it can be found. So many times you find things that just happen to be out there that you were not specifically looking, for there. Even put it on our LinkedIn page where it's out there, 4.118. So that's something to remember. And the changes in the code there. The Berkeley Pocket Manager has been around for a while. You could, in earlier renditions of it, you could put it into the kernel. For those that do their self-kernel situation, let me just make sure here. Yeah, we are now at 4.18.5. Let's see, when did it... that would be on August the 24th. That became a stable long-term. And so actually, if you want to get that, you can download the tarball or simply just patch it and upgrade yourself. We're still on the long-term. That is 4.114. That's the long-term stable one. And then, of course, you have, 4.17. And eventually it's like where we'll get up to 4.18 is our situation here. Let me start with some of our prepared this is Android Studio. Incidentally, if you want to develop on Android and don't have a device, always use Android Studio. And it is available, of course, for 16-bit Linux. And let me just... we will talk about Android 9. That is Pi. We'll look at it. That is the last, evidently, Android update. The last Android update. 10 will be a future. Fuchsia is a flower, a Japanese flower, but anyway, it will be a different operating system than what we have, and we'll talk more about it as we get Android Pi introduced here. And let's go back and just go ahead and introduce it. excuse me, Android Pie. This is from the Android developers people. Make your application compatible. Android 9 harnesses the power of artificial intelligence to give you more for your phone, and now it is smarter, faster, and adapts as you use it. Well, we won't get into testing. What is Android 9? A Pie here? Many new things here. There are many ways you can extend it. Notification updates, smart replay, data cost sensitivity and job scheduling, multi-cameras APIs, display cutout APIs, image decode for a bitmap, and a drawable, and more. Some of the things that are changing here, and this is the developers page. Let me just get over here to XD developers here. Anyway, Chrome and remote desktop updates add a notch of support in Pi and is resized there. While smartphones and tablets have replaced desktops and notebook PCs for many functions, there are still areas where it is preferable to use a PC with a desktop OS, and if you are outside with only a smartphone or tablet, you need to urgently access your PC. You can do it remotely. Now that in itself is one of the great things that are happening here. And let's see if we can. This is September 1. This is a new one. The Android smartphones and tablets replacing. Well, we went over that before. You can use the remote desktop solution, like the Microsoft remote desktop team viewer, or Google Chrome remote desktop solution. Requires you to have a Google Chrome or Google remote desktop extensions installed on your PC, while on the Android side you need to install the Android app to access your PC. The Android app was last updated in September 2017. Needs to be re-updated. That was support for Android 8. That was Oreo, but an upcoming update will bring support to devices with display controllers on the Android Pie. That would be the Google Play Store. So that's where we'll see that particular one. And let me see what else is here. This is one of the developer sites. We usually like to go to this particular site to get the updates that we were looking for here. These are some of the ports. List of Android Pie are 9 ports were announced, and the source code made available on AOSP, the developers community, and on our forum have been hard at work building fast the latest releases for their devices, although the stable official Android 9 releases are currently only available. Now, this is one of the drawbacks on the Google Pixel or Pixel AL, Google Pixel Z, etc., an essential phone. We see ports of the latest version making their way to devices as old as the original Motorola Moto G and OnePlus One. There are many devices on our forum that it's hard to find the first ports of Pi for your device to end I'm putting together a list of Android smartphones and tablets, and we'll link this one, have received an unofficial Pi ROM. Now, a lot of those devices are here, and we'll put those in. And some of the features, we talked about them, revamped access apps, revamped user interface, digital well-being application action, and slice APIs. Now, gesture navigation. So there are a lot of new things here. Now, some of these devices, the Asus, Google, this is a list of categories by brand that will list the ROM names in parentheses. Now, again, these are some of those in honor how we Lenovo, Motorola. Now, we talked about the Motorola Moto G, some of their devices, OnePlus, Samsung. The Galaxy Note 3 is one, and we have Sony and Wolfox. I'm not sure about them. ZTE, if you can find it. Axion 7 is a device there. And other devices, your device not on list, you still want to try it. You may find a choice device like the Razer phone, Huawei Mate 9, and some others here. And let's see, and more can experience Android Pi as they are Project Tenable compatible. You can follow in a page guide there, and you'll see if your device supports Project Trimby. If it does, you can find the Flash AOSP generic system based on Pi release there. And we'll just peruse the guide very, very briefly here. This is how to check if the Oreo 8 device is supported at Trimley. This was it. And it has some commands here that you can do to make certain of that. We'll put this on the Cranston Twitter feed, and also we'll place it up on the Facebook page, which is Cranston Software. We'll get some of this stuff up there for prosperity. And we'll check into this and see where 9 is. The more open source into development here of the code, and Project Trimble compatible, Trimbly compatible. One of the things here, so we'll look at this. And let's see where we are here. We have a little, well, this won't do us any good here. This is this is a different workstation, so we're not really going to that. So, okay, we did the Android Studio, and we'll do, let's see, the Netflix cloud service. This is at Linux.com, Netflix, cloud security. Release is Diffie. It's a different engine for the digital type of forensics in the cloud. The Netflix security intelligence and response team, that is SIRT, announced the release of Dippy. That's under the Apache 2 license. Dippy is a triage tool to help digital forensic and incident response. quickly the features here of it, and we'll put thing 2, Dippy, efficiently highlight outliners in the security, relevant instant behavior. For example, you can use Diffie to tell you which of your instances are listening on an unexpected port, are running an unusual process, including strange contab entries, or insert surprising kernel modules. Uses one and both two methods to highlight differences, a collection of functional baselines from a clean running instance against which your instance group is compatible. Clustered methods, etc., using modular plugins based on the architecture. We're currently including plugins for collections using the AWS, that's the Amazon Services EC2 System Manager, formerly known as Simple System Manager. Some of the things here with Dippy. You can find Dippy over at GitHub, and you can go there just under Dippy, Diffy, for Dippy. Okay, let's move along here. Some smartphone reviews. We won't go through these. This is from Tom's Hardware. Various ones out here that you can find, and they're all over the place. Some compatible to Moto G5 Plus, the Honor 7X, and they're excellent pictures, that sort of thing that are occurring there. So let me get back to the Linux roundup here. We'll call it, for lack of a better word. We started, of course, with the kernel, as we usually do. I guess Linux developers, Linux kernel developers, criticize Intel's meltdown on disclosure, and I think we'll go ahead and look at this one. This is an e-week. Haven't done them in a while. This is on August the 30th. An open source summit in North America. One of the leading Linux kernel developers took issue with Intel's initial disclosure of meltdown and Spectre CPU, and this is in Vancouver, British Columbia, and this was Greg Hartman here. Warned attendees about the severe impact of meltdown and Spectre CPU vulnerabilities could have on them, as well as details how the kernel developers are dealing with the flaws. I think this is pronounced Corner. Hartman is one of the leading world's leading Linux kernel developers with responsibility for maintaining the stable kernel, and is employed by the Linux Foundation as a fellow. During his talk, Mr. Hartman detailed the root impact and response of Linux kernel developers on variants of the meltdown. Jan Horn discovered the first issue. It was in 2017, in July. It was until October of last year that some of us in the kernel community heard rumors of the flaw, he said, and that's a long time. Meltdown and Spectre, and we've talked about it on this program. Vulnerabilities were first publicly acknowledged on the 3rd of January by Intel. The original research was reported to Intel by multiple researchers, including Horn from Google. Project Zero said that when Intel finally decided to tell Linux developers, the disclosure was out. Naturally, when we get a kernel security bug, it goes to the Linux security team We drag in the right people. We work with the distributions, getting everyone on the same page, and push out the patches. From the initial set of vulnerabilities, Corona Hartman said the different Linux vendors, that typically work together. However, in this case, they ended up working on their own. Not a good thing. Each came up with a different solution. It really wasn't working, and a number of us in the kernel development yelled at Intel and pleaded. We finally got them to allow us to talk to each other the last week of December 2017. All of our holiday vacations were ruined. This was not good. Intel really messed up on this. The Linux kernel is developed and run by a wide variety of organizations, therefore both corporate kernels that are backed by large vendors as well as community kernels. Corona Hartman said the majority of the world does not run on a corporate-backed Linux kernel. He noted that Intel is used to working with companies and only initially worked with corporate vendors on Meltdown and Spectre. Intel's response to Intel's critic, Corona Hartman said that after the developers complained loudly to the company in December and into January, a fix disclosure process for the future Meltdown and Spectre. Right, and incidentally, this has raised its ugly head in some of the other Intel processors more recently. The recent variants of a Meltdown and Spectre, which have been dubbed Foreshadow, was publicly disclosed on August the 4th. That's the one we were talking about. Colonel Hartman said the Linux developers were properly notified ahead of time so that the fix could be made in collaborative way by the Linux community. Intel has gotten better at this. Interesting side effect of Meltdown and Spectre vulnerabilities is that Linux and Windows developers are now working together since both operating systems face similar risks from the CPU vulnerabilities. Windows and Linux developers now have the wonderful back channel that we are talking to each other and we are fixing bugs for each other. It's Conor Hartman. And we are working well together, and we always wanted that. Fixing the flaw, all reports of Meltdown Spectre vulnerabilities have been fixed in all modern supported Linux kernels. According to Conor Hartman, he warned, however, that not all fixes have been backported to the older 4.4 kernels and advised users not to run any untrusted code on systems running that kernel. And this is where it's very, very important to upgrade your kernel on production and non-productive systems, because you want to be updated, and you should have the 4.4 kernel and moving towards 4.4.18, or at least the long-term kernel like we have in Slackware. I think that's 4.62. And to finish this up, there's been many patches made in Linux. He strongly advised users to update the Intel microcode fix, as well as they provide additional types of layer protection beyond what the operating system can do. Colonel Hartman warned that Meltdown and Spectre issues will be around for a long time, as new variants are likely to emerge. The fix for the initial Meltdown, Spectre and variants, have required a lot of effort from kernel developers. We are not going to be playing whack a mole for the next 10 years. Colonel Hartman said that there needs to be a reliable way to automatically find the bugs and to have the updates compiled that detect vulnerability code patterns and remove the flaws. Research is ongoing on different ways to accurately detect meltdown and spectre issues. Security always has been important, and that's another variant there. So this is from the Linux Developers Conference at eweek.com. And this was the conference in Vancouver. And let me just go to it and we'll review it. This is one of the big ones, no doubt about that. And this conference actually has just ended. This is August the 27th and 28th in Vancouver, and August 29th and 31st. So the Open Source Summit, the Linux Foundation's Open Source Summit, and a proper review of it, and through the 28th, and they had a lot of different workshops there, no doubt. Some lightning talks, as we usually have. Just looking at the program here. Technical documentation at scale is one day. They have the keynote, the open source and a decentralized web. That was Sean Wilkinson, founder, and Ben Gobob there. And some others here, some showcase events, as they always have. Is there an open source business model? Yes and no. And somebody from IBM that brought that up. There's a mixture of people here. The commercial people get in. There's no doubt about that. And just looking at some of the programs that they had along here. And I'm looking at the actual program. They had the Apache Way. I'm just going over some of the titles of the presentations as we move along. And this is kind of interesting here. On Thursday the 30th, they had Van Jones, president and founder of the nonprofit Dream Corps, and he's a CNN contributor. And they had a best-selling offer, etc., there. Van Jones was in the Obama administration, had a low-line functionary role there in the environmental sphere. But at least they had him there at the conference. And someone from Intel was also there. So it's, a long variety of people. No doubt, as you would always have at these types of conferences. They have thanks for attending, and they show Willow Snyder was there, Van Jones, etc. People that spoke. And I assume we can hear Lennox Talbot was actually there too. Didn't get it. I'm just looking at some of the speakers here. There were a lot of different speakers at the conference.
Well, so thank you for the few minutes I have to talk to you today. I want to talk about what we call multimodal IT. So I really love...
We'll play this, and let me just take a commercial break. This is WBRN Radio, beaming on the Boston Red Network, and we'll go to that conference when we return. At least we'll hear a little bit of it. I have some of the keynote speech here.
Well, so thank you for the few minutes I have to
Clark.
talk to you today. I want to talk about...
He's at SUSE.
What we call multimodal IT. So I really love this conference. I really love the gathering we have here, because we're here talking about all kinds of new technologies and how those technologies are going to change the world, right? So everything from machine learning to AI to robotics, to Internet of Things, to edge computing, to big analytics, right? We're talking about all these technologies. And they are changing our world, right? And they're making things better. We're getting things that are, the goals are to become much more agile in our services, in our businesses, and the types of services we're delivering to our customers and to our clients. We're making those services better for them in the way they can consume those. And we're able to deliver technology much faster today than we could before. And I'll give you a couple examples here in a minute. And also drive efficiency. But the interesting thing about this is, if you think about it from our perspective as users, we're kind of like a hammer. I love this picture because the hammer in this picture is you and I. Our expectations for the types of services has gone way up. Every one of us has our little smart devices that we carry around, right? We're traveling around the world. Our expectations are way up here as to what those services are provided to us through this little device, right? I expect the same serviceability. I expect the same accessibility, regardless of whether I'm sitting in Vancouver or I'm sitting in Berlin or I'm sitting in Beijing, right? So we've developed this hammer, and beyond that, we've got an inkling for the new things that are perhaps even possible, right? Think about the voice-activated AI that we have today, right? We can ask our phone and it'll tell us all kinds of information. That starts to create these new ideas of what is possible and what we can do. Well, us as a hammer, all of a sudden that's putting a lot of pressure onto the IT departments and the businesses that are going to have to deliver those services. And you can look at that two ways. It's either a hammer and they're a nail, or you can look at it and say, new, great opportunities that can come about. And the very interesting thing, in a lot of conversations I have with people, is those new things are happening in open source. So it becomes a question, and the answer becomes leverage open source. Leverage open source. So to do that, I want to give you an example. And it's not just pulling an open source piece or an open source project and running on your way, but what we're really finding is the power is to combine those technologies together. And I just wanted to throw an example here through SUSE's application rapid delivery platform, okay? Everybody's familiar with Cloud Foundry, particularly here today in this audience. Everybody's familiar with Kubernetes. The power is putting those together. Once I put those together, I get that rapid application end-to-end deployment model, right, development model. By combining with Kubernetes, I've now made that much more easy to deploy. The next step is, at SUSE, we've taken containers to heart. So not only have we put those two technologies together, but you add in the latest notion of containerization. I've now made that so it's a much more rapid deployment model. I've made that so the footprint, memory print, all of that is reduced, which means my scalability goes up. I've also increased my portability, which means I can push that workload to wherever it needs to be. Okay? So that's just an example of how we take these latest technologies. By combining those together, I can create much more diverse and powerful services to deliver to my customers and to try to meet those expectations created by our hammer. Now, if you look at this from an IT perspective, what this means is they've got to go through a transformation, right? Those demands that we're placing on them means that they've got to transform to meet that. And it's not just in the application delivery space. It's there, right? But it affects the way they develop software. It affects the way the applications are architected. It affects the way those applications are deployed. And it goes clear down to the very infrastructure of IT, right? Going from a data center to cloud models, going from physical servers to virtualized servers, which we've been doing for years, going to containerizer microservices, going from monolithic applications to microservices, even our development models, right? Going to a much more agile model. All of those are impacted, all of those are affected. That's quite powerful, but it's also quite challenging. So we end up in this state of what we call multimodal IT. Okay, this is where IT has an existence of traditional infrastructure, where they've got what we now call, and you're all familiar with the term, software-defined infrastructure, and rapid application-oriented architectures, right? So I've got data center trying to live with cloud. I've got physical servers. I've got virtual servers. I've got containerized services. I've got monolithic applications. I've got microservices. I've got n-tier services. I've got, hopefully, not too many waterfall development processes anymore, but I've got agile development processes and DevOps types processes. How do I handle that? I can either create a bunch of silos, or I can figure out how to make those work together. And I want to give you an example here. We've only just got a couple minutes, so I can only take time to show you one, to show you what I mean by multimodal. Okay? So going back to my example here with the smartphone, think of a banking application, for example. It's very common. Most likely, the apps that are running on your phone have been developed using the latest development technologies, right? Agile development, microservices type style development, breaking those apps down, delivering fast, delivering often, updating often, and so forth. But on the back side, those traditional services, particularly like in a banking application, you're going to find that data, your financial data, your paycheck, are sitting in some traditional infrastructure, particularly back on perhaps your employee data and so forth, information sitting on some SAP server somewhere. Could be back on an Oracle server, for example, right? So you have this mixture of both traditional and software-defined infrastructures, and you've got to marry and meld those together. Otherwise, you end up in a siloed scenario. So what multimodal IT, what the IT department needs is bridges, right? You could go for a rip and replace model. Can't happen overnight. Instead, you want to leverage the strength of both, because there are strengths in both models. And you want to be able to leverage those. So you want to leverage and use containers, for example, in your data center. How do you do that? You want to be able to move your workloads from on-premise to the cloud. Makes total sense, right? You want to be able to take and make those workloads agile. How do I do that? Well, I haven't got time to go through the whole stack and explain the whole stack, but I wanted to take just a minute and talk about the very lowest level, right? We're here at the Linux Foundation. We talk about Linux. So let's talk about it at the operating system level. And to really take advantage of this, you need something what we call a multimodal operating system. Now, if you think a lot about Linux, it's been around for 25 years. Traditionally, years ago, what we used to do is, and if you remember, you could get Linux in a box, right? And in that box, you'd have multiple DVDs, and those DVDs contained everything in the sun, multiple desktops, every hardware device you could think of, all different types of software extensions that you could think of. And the installation basically went through and installed everything, and then the IT manager had to go through and figure out how to pull things out that he didn't want, turn off ports that they didn't need, tie it down so that it was secure. So it was very much install everything, take out what you didn't need. Well, we've quickly learned, and with the advent, the huge pipes we have on the internet today, we've been able to turn that around. And it began with breaking things out, trying to make things more modular. Where to the point we are today, and going forward in the future, we've flipped that around. So the notion today is, let's install the smallest footprint that you need, and make it very, very simple to add the services that you want. Okay? So we call this a modular operating system. And it turns out that it's very tongue-tied there for a bit. Perfect for a multimodal environment. And let me show you why. Okay? So in a multimodal environment, you've got your traditional infrastructure and you've got your software-defined infrastructure. What this means is I have devices that could be as small as a Raspberry Pi, right? All the way up to devices that are as large as a supercomputer. So the Raspberry Pi, I want a very small, very dedicated footprint up to the supercomputer where I'm going to take advantage of a very large memory and perhaps storage footprint. But I want to tailor that so I can use my small devices for edge. I can install and do very particular devices. Let's say, for example, running an HPC environment where I'm adding on machine learning, right? I can tailor that operating system and tune it so I can run it in a public cloud environment like Microsoft Azure. I can tailor that environment for the latest constructs with memory, so like NVE or NVM, where I can take advantage of that non-volatile memory to run processes for data analytics, for example. I can take advantage of the strength of the architectures in the mainframe to run those legacy applications. I can take advantage of the scalability and storability, compute-intensive power that you can provide through Linux all the way up to the supercomputing environment. That's why you're seeing Linux spread across all those, giving me that modularity where I can focus and tune Linux for those particular environments is the strength that we have. Now, the second part of this is
okay, we basically left him behind, but nonetheless, to sort of
Linux is my favorite thing. It was and is my favorite.
This is a 7-year-old that created a particular port. Now, let me just, this is 2 years ago. I was going to get Linus Torvalds, but that was from 2 years ago, not very up-to-date. Is sometimes what you run into. But again, these keynote speeches by various people, I'm not sure. Not here. They don't really have a listing of the speakers here, but this conference, SUSE, however they want to pronounce it there, started out in Intel, some of the so-called diamond people here, and IBM. You can see the commercial aspect of Red Hat, the Amazon operator, Google, Microsoft in here, SAP, and various others, Adobe mixed in here with these other people, and some of the companies, OpenSwitch, etc., open a API into a Linux conference, the Linux Journal, the Linux.com, and various others. Just looking at, we actually do have linuxquestions.org. These are media partners there of these, which we put ourselves as one of their media outlets at WBRN Radio and on the Boston Red Network. So we're all here, and we look at the speakers here, some diversity. They had Van Jones there. They had Sean Wilkinson and Angela Diaz, and just some here that shooting across here. Wendell Snyder, we already mentioned Wendell Snyder, Torvalds, Jennifer Close, Patricia, and various others. So in other words, the Linux people have changed from what we had at one time. That Linux was more of a closed type model, and of course now it is no longer that. So we are seeing more diversity, the real world mixing in, and some criticism of open source. And again, this is through the Linux Foundation. You can expect that is more of a commercial oriented. We had SUSE there as a sponsor. And of course, they're pushing their own implementations of there, and the other corporations are also. So that's keeping many of the developers in the quote-unquote commercial orbit. As Connor Hardman mentioned, most of us Linux developers develop on the non-commercial implementations of Linux, and that is obviously the way to go. And we have to understand there are millions of Linux developers out there that run servers of their own for various purposes across the sun. So this is very important when you bring in the concept of Ubuntu, and as long as the kernel is freely available, you have open source. Libra software is very important. The other underlying chatter there from the Intels of the world, etc., the Red Hats of the world. I didn't see AMD here, but as one of the sponsors of this conference, but the Linux hardware software will run on it, and the hardware vendors weren't here, and I don't know if we had an open hardware vendor or not. We see Red Hat Native Cloud. I'm not sure what Datadog is. They're pushing now the Linux Academy, a big one there. Adobe used to be with the PDFs and the Adobe applications. Now Adobe is very, very big in analytics. They provide analytical information of all types here. So some of the newer entrants in this, community partners, they are there. Open Nerd, Lighthouse Laboratory, Open HPC, our ladies. Had not heard of them before, but they are there. Their time has come. The complete list of all the meetup locations. There's a meetup location for them in San Francisco, and of course in Boston, in L.A., in Nashville, Tennessee, in New York, Barcelona, Spain, Lima, Peru, Berlin, in the German, Lisbon in Portugal, Hartford, Connecticut, Ames, Iowa, in the Midwest, Washington, Austin, Texas, let's see, Ontario in Canada, Cape Town in South Africa, Miami in Florida, Orlando, Chicago, Mexico City, just naming some of these. This is where the Lady R's meet. The Twin Cities in Minnesota, in St. Louis, Missouri, Irvine, California, Santa Fe, Argentina. So there's just some in Baltimore, Maryland, and in Amsterdam in the Netherlands. So those are just some of the various organizations out there. And we look at the open source movement that is growing daily. This is going to do it for us on the 2nd of September 2018 from WBRN Radio and on the Boston Red Network. Our sponsor, as usual, is Cranston Software that has units in various locations where we virtually are co-located or whatever. We're around. And our Twitter feed, of course, at Cranston Software, where we dispense the events of the day, the hour, etc. And on the Cranston Software Facebook page, we bring those out. We're going to need to put up a YouTube channel. WBRN Radio has a YouTube channel, and of course we'll be appearing on it also. We're on the iHeart app. There are 800 iHeart stations. You can go there and find the open source report. You can find us on Stitcher, on YouTube, Speaker, and various other smart devices, whether it be Chrome, whether it be Alexa, that's the Amazon virtually just say open source report, and we should pop up. And we need to check if we're on the Android side there or the Google side. Some of these sides are a little bit different to get there, but we will eventually get there. And of course, you can find us the open source report at bostonred.com and also .org, and also at crassussoftware.com. We'll put up some of the latest things that we covered today there. Good day.